Okay, in this video, I'm going to give you an overview of factoring. It's going to hopefully break out into subsequent videos about the different methods of factoring. And right here, I'm going to demonstrate some factoring ideas that I'm not going to give you the details of. I'm just going to give you the broad strokes. So you'll see some things happen in this video that you don't get in detail, but those details will come in subsequent lessons and subsequent videos. Okay? So I'm going to try and do this in an organizational chart because factoring is a really big area in algebra. And it's used continually after algebra and pre-calculus, calculus, and then some. So let's take a look. First with factoring, let's have a working definition here. We want to say that factoring, it's a process of writing an expression as a product. Okay, most often it's given to us as a sum or a difference, and we write it as a product. And a product means we're going to write it as a multiplication problem. Okay, so then we've got the methods of factoring, okay, of which there are several. Okay, so for our methods of factoring, the first one that we always tend to look for is something called greatest common factor or undistribution. Okay, and then we want to be mindful of looking for some special pattern factorings, and they could be something like a difference of two squares or a perfect square trinomial. Okay, and they have special patterns for them that we'll talk about in a bit. Okay, then from there we want to be able to try to recognize two types of quadratic trinomials. Okay, there are easy quadratic trinomial problems, and there are harder quadratic trinomial problems. Okay, and then in the end, one of the things that can be factored also is something called a sum or difference of two squares. Excuse me, two cubes. Okay, that's also done with a special pattern. Okay, before I continue to develop this flowchart in any, or this concept map in any particular way, I want us to put some focus on the idea of writing an expression as a product. Okay, and to do that, I'm just going to show you some factoring problems that involve a variety of these methods. Okay, and again, there's going to be details here and methods here that you haven't been taught, but let's just focus again on this overview of writing something as a product. Okay, now for a number like 12, this is very basic. I could take this and write it as 3 times 4. This would be having applied a factoring process to 12 by writing it as this product of 3 times 4. Now I could have factored that different ways. Obviously 1 times 12, 2 times 6. Also, I could have done 1/2 times 24. That's a product as well, which brings up the point that when we tend to factor in the most basic rudimentary form, we tend to look for whole number and integer opportunities when we're factoring. Now, looking at this next problem, you might not know how to write it as a product. If we notice here, it's in fact a difference of 24x minus 18. And without exactly telling you how to do it, I just want to show you that it's possible to write this as a product. I'm going to write this as a product of 6 and 4x minus 3. Now, once I've written the answer, you may see this very quickly that it's equivalent because if you notice, 6 times 4x is 24x, and 6 times negative 3 is negative 18. So the one thing we see is this difference can be written as this product, and this product can be distributed out and written as that difference. So there is this element that we get this complete cycle going on, is that these expressions are equivalent. Okay? Now in this next problem, it's m squared minus 81. You'll see later on that this is something called a difference of squares. And it has a unique pattern that I can factor it with. And it'll be two quantities. And the first quantity will be m minus 9, and the next quantity will be m plus 9. Now, not exactly sure how I got that. That's fine for now. We're going to demonstrate this method later. But if you notice, when I FOIL this out, or multiply it all out, I'm going to get m times m is m squared. I'm going to get m times 9 is 9m, and negative 9 times m is negative 9m. Well, 9m minus 9m is going to cancel. And then I get negative 9 times 9 is negative 81. So again, I was able to write this expression that is a difference as a product. It's a product of two quantities, the quantity of m minus 9 times the quantity m plus 9. Okay, now in this next example, we see we have a trinomial, and it's an easy quadratic trinomial to factor. Again, if you know how to factor it, which you might not at this point. But I'm going to write this as a product of two quantities, and the first one is going to be y plus 8, and the next one is going to be y minus 3. And I know this is accurate. If I FOILed it all out, I would get y times y is y squared. And then I would get y times negative 3, and 8 times y is negative 3y plus 8y, which is 5y. And then I would get 8 times negative 3 is negative 24. And again, we're trying to just give some focus to the fact that this sum can be written as this product. And that product, in fact, can be FOILed out and written as that sum. Okay? So this last one, if we notice here, it just looks like it's two terms. It actually factors into something quite large. This is an example of something called a difference of cubes. Okay? So interestingly enough here, this will blow you away that I'll just write the answer on the board, but in subsequent videos when I show you how to do this, you're going to do it as well as I do. So I actually know that this is going to be the quantity of x minus 3 times the quantity of x squared minus, excuse me, it's actually plus 3x and plus 9. Now, I won't factor this out with the magic pen because this is a little more to see. Again, the grand question here is, in fact, is this difference equal to this product of the quantity x minus 3 times the quantity of x squared plus 3x plus 9? Well, let's take a look. I'll do two colors here. I'll do x times x squared, x times 3x, and x times 9, which is going to give me x cubed plus 3x squared plus 9x. And then I'll do, down here in green, I'll do negative 3 times x is negative 3x squared. Negative 3 times 3x is negative 9x. Negative 3 times 9 is negative 27. Well, we're going to notice from there that we get the 3x squareds cancel, and then the 9x's cancel. So in fact, the only thing I'd be left with if I simplify this is x cubed minus 27, which is the original problem. So the overview here that we're just trying to get you to see is that the process of factoring is taking an expression and writing a product. 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 We did this in every problem, even in this last problem that is very beast-like here. I'll just take out the junk, okay, and you should be able to see that, in fact, these expressions are equivalent. Now, obviously I haven't showed you how to do any of these, but I'm just trying to show you there's a real variety of problems, but underlying them all is the definition of writing an expression as a product. Okay, from here, where does that bring us? I think that brings us to a good time to bring up this question. And that question is, why? The question is, why do we factor? Okay, well, that's a great question. And that question I'm going to elaborate for several reasons, two of which I'm going to show right now, and I'm not going to show a third because, to tell you the truth, there's many reasons why we factor. So there's an element where it's like there's many answers to our why, but I'm just going to focus on two reasons right now. And these two reasons are that, one, factoring helps us simplify expressions, and factoring helps us to solve equations. Okay? So all of these methods here that you're going to learn, often they are not ends to themselves. They become steps in other problems. And those problems, in fact, will involve simplifying expressions, solving equations. And like I said, there's many other reasons that this happens throughout math, but these are the ones that you'll start to delve into it once you start to do factoring. So let's take a look at what that actually looks like real quickly. Okay, so why factor? It helps us simplify expressions. It helps us solve equations. For example, if I took this quotient, you notice up top there's a difference, and on the bottom there's an actual sum. Well, by factoring this, and again, you might not understand exactly how I'm factoring it, but you'd see that x squared minus 9 can be written as x minus 3 times a quantity x plus 3. Okay? And then this bottom quantity actually could be factored into the quantity x plus 3 times the quantity x plus 3. Okay? Again, you could just FOIL these out and see that the expressions are equal. You could do this for the numerator and see that they're equal, and you could do this for the denominator and see that they're equal. Well, from here you could see that in this expression I can cancel the x plus 3's and just write x minus 3 over x plus 3, which allows me to simplify the expression. Okay? I won't put any focus or attention to the fact about restricting the denominator or what have you. That's a longer discussion. There's a little more to this problem, but this is the crux of it. Okay, and if you're going to solve an equation like x squared minus 6x plus 8, methods by which you would sort of start doing something like, oh, I'll subtract 8 from both sides and try to undo my operations, that's going to take you nowhere fast in a problem like this because it's more complex. So there's multiple methods for doing this, but factoring is one of them. If I could write this expression as a product, it would allow me to apply a unique concept. So first let me do that. And I'm going to see that this is the quantity x minus 2 times quantity x minus 4. And I'll pull down the equals to 0. And again, if I FOILed this out, I'd get x times x is x squared. I get negative 4x and negative 2x is negative 6x. And then I get negative 2 times negative 4 is positive 8. So it's obvious that these two highlighted expressions are actually equivalent to each other. Okay, now from here, this will be a lesson in the future as well, you can do the following. You can see that you've got two factors here whose product is 0. Well, if you think about that, the only way that that's possible to multiply two numbers together and get 0 is that one of them has to be 0. So, from that logic, I could actually split this up into that the first factor is 0 and the second factor is 0. So here I'd see that x equals 2 or x equals 4. Okay? So again, it took a decently complex equation by which I solved it, okay? And I had to, in fact, factor to do it. I had to be able to write an expression as a product, because this trick of saying that I can split the factors and set them both equal to 0 can't happen unless it's a product. Okay, so this is just the rough overview. So where are we going to go from here? Well, from here, I'm hopefully going to elaborate this chart in subsequent videos, okay? And now that you get the basics that, one, Factoring is a process of writing an expression as a product. 2, there are several methods of factoring that we must master. And 3, you have a little bit of an idea of why we factor. I think you're ready to attack some factoring work. And there's no place as good as to start as that as with greatest common factor and undistribution. Okay, undistribution's a nickname for it. But little word to the wise: anytime you set out to factor, you should always ask yourself if you can do this greatest common factor method first. So hopefully you're going to move yourself to the next instructional video, which is learning how to factor with greatest common factor. Enjoy.